The widespread adoption of artificial sweeteners as sugar substitutes reflects intuitive appeal, maintaining sweetness without caloric consequences. However, emerging research challenges assumptions about cognitive safety, revealing a complex picture that defies simple risk-benefit calculations. Recent long-term cohort studies present concerning signals. An 8-year Brazilian study tracking thousands of adults found associations between regular artificial sweetener consumption and accelerated decline in verbal fluency and memory performance. Similar patterns appear in European datasets, with certain non-nutritive sweeteners correlating with cognitive outcomes comparable to or occasionally exceeding risks observed with sugar itself. These findings contradict the presumed neutrality of zero-calorie alternatives. The sweetener landscape proves heterogeneous, with different compounds exhibiting distinct profiles. Aspartame, sucralose, saccharin, and newer options like erythritol each interact differently with metabolic and neurological systems. Some mechanistic research in animal models suggests potential disruption of gut microbiome composition, which increasingly appears relevant to brain function through the gut-brain axis. Other studies indicate possible interference with glucose metabolism regulation, paradoxically impairing the very systems artificial sweeteners aim to protect. Regulatory bodies maintain approval status for common sweeteners based primarily on acute toxicity studies, yet these evaluations may inadequately capture subtle long-term neurological effects. The gap between regulatory confidence and emerging observational evidence creates legitimate scientific uncertainty. Importantly, null findings also exist. Multiple studies detect no cognitive associations with moderate sweetener use, and some researchers argue that observational correlations reflect confounding by indication. People consuming artificial sweeteners may already possess metabolic or health conditions driving cognitive risk. Disentangling cause from correlation remains methodologically challenging. The mechanistic plausibility varies by compound. Some sweeteners show minimal biological activity beyond taste receptor stimulation, while others demonstrate measurable effects on insulin secretion, inflammatory markers, or neural signaling pathways. The diversity of sweetener types complicates attempts to generalize findings across the category. From a precautionary perspective, the accumulating evidence suggests reason for pause. While definitive causal proof remains elusive, the pattern of worrying signals across multiple compounds and populations merits attention. The original promise of artificial sweeteners' risk-free sweetness appears increasingly questionable as research methodologies improve and longer-term data accumulate. Practical recommendations increasingly favor the most conservative approach, transitioning away from both sugar and artificial sweeteners toward unsweetened or minimally sweetened options. Water, unsweetened tea, and beverages relying on whole fruit for flavor avoid both known sugar risks and uncertain sweetener risks. For individuals seeking cognitive health optimization, the evidence increasingly suggests that training taste preferences toward less sweetness overall constitutes the most defensible strategy, eliminating concerns about either category while potentially resetting hedonic thresholds that drive overconsumption.